Now we're in chapter 2.7 and we're going to be solving linear inequalities. Our first objective is to understand properties used to solve linear inequalities. The first property we learned was the addition property. It said that we can add or subtract the same number on both sides of the equation without changing the solution. We can do the same with our inequalities. Here's an example. We have 2x plus 3 is less than 7. When we're solving for x, so the first thing we're going to move is the plus 3, and we're going to move it by subtracting 3. And we will end up with 2x is less than 4. And then the next property was the multiplication property. It said we may multiply or divide by the same number on both sides of your equation without changing the solution. So we can do the same thing with our inequalities. So continuing the example from the last slide, we had 2x is less than 4. Now we want to move the 2, so we divide by 2 on both sides of our inequality, and we're left with x is less than 2. Then we have the negative multiplication property. Remember that when you divide or multiply by a negative, you have to flip your inequality sign. So for this example, we start off saying less than. We have negative 4x is less than 20. We divide both sides by negative 4, and we'll end up with x, and then we switch our inequality sign is greater than negative 5. So if you multiply or you divide by a negative, then you must reverse the direction of your inequality symbol. Okay, now we can move on to objective 2, which is solving linear inequalities. So the steps for solving a linear inequality, same steps as before. Step 1, you're going to simplify. Remember, we simplify by distributing and combining like terms. Step 2, we're going to use the addition property. So anything adding or subtracting would be moved. Step 3 is the multiplication property. So anything multiplying or dividing. Remember, if you multiply or divide by a negative, then you need to reverse the inequality symbol. And then step 4, we're going to express our solution in interval notation and graph it. All right, let's go in our books to page 195, and let's start by looking at number 66. The instructions say use both the addition and multiplication properties of inequalities to solve each inequality. And for number 66, we have 3 minus x is greater than or equal to negative 3. So here we're going to treat our greater than or equal to just like an equal sign. We can draw the line down it. So the first thing we need to move is the 3, because we're solving for x. It's a positive 3, so we're going to subtract 3 on both sides. And we'll get negative x is greater than or equal to negative 6. Then we need to move this negative, which means we're going to divide by negative 1 on both sides. We'll have x. Then remember to flip your inequality symbol. So now x is less than or equal to positive 6. So we have that x is less than or equal to 6. This is our solution. So now we're going to go ahead and graph our solution. So to graph, you're going to draw a number line. And then go ahead and put the 6 on the number line. And if you need to, you can put other numbers like 7 and 8, and then 5 and 4. Now, because it says less than or equal to, you're going to use a bracket. So if the symbol is less than or equal to, or if it's greater than or equal, you're going to use a bracket. This bracket can face to the left, or it could face to the right. It's the equal sign that indicates the bracket. Bracket means include the value. So for number 66, we have x is less than or equal to 6. Therefore, we're including the 6. So on the 6, we're going to draw a bracket. Now, because it says less than, it's going to face to the left. And then we're going to shade everything to the left. and then draw an arrow. So here's our graph. Now we must write it as an interval. So the interval is written as the minimum, comma, the maximum. So what's the smallest x can be and what's the largest x can be? Well, if we look at our graph, we see the arrow is facing all the way to the left, which means it's going to go on forever all the way to the left. So the smallest it is negative infinity, comma, the largest would be 6, because we're here. Now we need to close these. Well, on your infinities, negative infinity as well as positive infinity, you always put a parentheses. And then on the 6, because it said less than or equal, we're going to have a bracket. So this is our interval. All right, let's look at number 70. And we have 4y minus 7 is greater than 9y minus 2. And here we're solving for y. So let me get my y's together first. I'm going to subtract 4y on both sides. On the left side, I have negative 7 is greater than 5y minus 2. Now we're solving for y, so we need to move the minus 2. So we're going to add 2 on both sides. And we get negative 5 is greater than 5y. And then the last step would be to divide by 5. So we have negative 1 greater than y. So how you really read inequalities, you always read from the variable. So even though the variable is on the right side, we're going to say y is less than negative 1. So this really says y is less than negative 1. So here's our solution. Now we can graph it on a number line. So let's draw a number line. We'll put the negative 1 on there. We have 0. We have negative 2. And if you want it, you can put as many numbers on your number line as you need. Now, because this says less than, says y is less than, there is no equal sign underneath it. You're going to use a parentheses. So if your inequality symbol is less than, or if it is greater than, use a parentheses. The parentheses could face to the right, or it could be facing to the left. This means do not include. So for our example, it says y is less than negative 1. Therefore, we will not include the negative 1. So on negative 1, you're going to have a parentheses. Because it says less than, it's going to be facing to the left. And then you're going to shade everything to the left. And then draw an arrow. And here's our graph. So now what we're going to do is write our interval. Notice that on your graph, you have your interval. Who's all the way over here to the left? It's negative infinity. So that's where we're going to start. So negative infinity, comma, we run all the way into negative 1. Remember, on negative infinity, it's always going to be a parentheses. And then on our negative 1, it's a parentheses because it says less than. And there's our interval. Now number 72. We have 4 times 2y minus 1 is greater than 12. We're going to solve for y. First thing we need to do is distribute. So we have 8y minus 4 is greater than 12. Remember to multiply everything inside the parentheses by 4. Now we solve for y, so we're going to add 4 on both sides. And we have 8y is greater than 16. And then we finish off by dividing by 8. And we have y is greater than 2. So here's our solution. We're going to graph it. We have y is greater than 2. Because we have a greater than sign, we're going to use a parentheses that opens up this time to the right, which means we're going to shade everything to the right and then draw an arrow. So here's the graph, and then which means the interval, this time it's switched, so the smallest is 2, and then the largest all the way to the right is positive infinity. On the 2, because it's greater than, we have a parentheses, and then on infinity, because it's infinity, we also have a parentheses. So here's your interval answer, here's your graph, and then there's your solution. Now, objective 3 says identify inequalities with no solution or true for all real numbers. So there are some inequalities that either have no solution or infinitely many solutions. When solving these type of inequalities, all of your variables will become eliminated, and you'll either get a sentence that is true or one that is false. An example of a true sentence would be 4 less than 8. Because 4 is less than 8, this is true. And then an example of one that's false would be one like -4 is greater than 5. This is actually false. If you end up with a true sentence, then your answer or your solution would be infinitely many solutions. You're saying X can be anything, basically. If you end up with a false statement, then your solution is no solution. Let's go in our books to page 196, and we'll start by looking at number 83. The instructions say solve the inequality. For 83, we have x plus 3 is less than x plus 7. And let's solve for x. So first we're going to get our x's together. So how do you move the x? You're going to subtract x on both sides. You'll end up with 3 is less than 7. That's because our x's canceled out. Now 3 less than 7, that is a true statement. Therefore, your answer is infinitely many solutions. And you can write it as an interval as negative infinity, comma, infinity. This means it includes the entire real line. So for any x's that you pick, if you plug it back into your inequality, you'll always end up with a true sentence. And then number 85, we have 7x is less than or equal to 7 times x minus 2. So we're going to start by distributing the 7 on the right side. And we'll get 7x minus 14. Now let's get our x's together. So I'm going to subtract 7x on both sides. On the left side, we get 0 is less than or equal to negative 14. This cancels out, so we have negative 14. Now is 0 less than or equal to negative 14? That isn't true, so it's false, which means the solution to this problem is no solution. You can write it in words as no solution, or you can write a circle with a slash through it. That also means no solution. So it doesn't matter which x you pick or which number for x you pick. When you plug it back in, you'll always end up with a false statement. For your infinitely many solutions and your no solutions, you do not have to graph them on a number line. Objective 4 is to solve problems using linear inequalities. So in our books on page 196, problem 107, part A, it says on 2 exams you have grades of 86 and 88. There is an optional final exam which counts as 1 grade. You decide to take the final in order to get a course grade of an A, meaning a final average of at least 90. So we have 2 exams, we got 86 and we got 88. We have a final exam, which I'm going to call X. And then we want our grade to be at least an A. In part A, it says, what must you get on the final in order to earn an A in the course? So we want our average in our class to be an A. Remember how you find average. You're going to add up all your grades, so 86 plus 88 plus X. And you divide by how many there are, which are 3. And we want this to be at least 90. So at least means greater than or equal to 90. And then in the problem, they want you to find what you have to get on your final exam. So let's solve for X. This time, so let's first start by combining our like terms. So 86 plus 88, so that's 174 plus X divided by 3 is greater than or equal to 90. Now this time, instead of moving the 174 first, we're going to move the 3. So in order to move the 3, we're going to multiply both sides by 3. Multiply both sides by 3. Cancels out. And we have 174 plus X is greater than or equal to 270. Now we can move the 174 by subtracting on both sides. And we have X is greater than or equal to 96. So if your final exam has a grade of 96 or higher, you'll get an A in the course. Okay, this will conclude our video for Chapter 2.7. Please email me if you have any questions.